Students, hello students. Today we are going to learn about memory management, the third chapter. Before we are discussing about the memory management, first let us see the contents or outlines of this memory management. First, we will have to introduce what is memory and types of partitioning techniques, that is fixed partitioning, dynamic partitioning. Moreover, we will also see relocation and protection. We will also discuss about virtual memory and paging and segmentation. Okay. To define a memory is one of the most important parts of the computer system that is to store data and a program. So a computer memory plays a significant role to store either a data or a program. So the part of the operating system that manages this memory is a memory manager. There are different types of memory in a computer system. These types of memory is managed by the part of the operating system. This referred to as memory manager. So the role of memory manager is in order to manage or control the operations of a memory. The main function of the memory manager are the following. For example, this memory manager keeps track of the memory which are used under the computer system. That means it keeps track of which part of memory are in used and which one is free. It tells or keep track of such information. The memory manager also helps to allocate and deallocate the memory to a process. Allocating a memory means giving memory for a process, and the allocation means just release a memory from a process. This is managed or controlled by the memory managers of the operating system. So managing swapping between memory and disk when memory is not big enough to hold all the process. So memory must be managed properly, since a memory is one of the big important in a computer system. Just if there is no memory, we may not run the programs or data properly in our computer system. So memory should be managed effectively and efficiently. So a good memory manager has the following attributes or criteria. The first one, it allows all process to run, and its use or its memory overhead must be reasonable, and its time overhead is reasonable. That means memory overhead must be reasonable, time overhead must be reasonable, and it allows all process to be run on a computer system. This is the good quality of a good memory manager. So memory management scheme. The memory management scheme, there are a number of memory management schemes ranging from very simple to very high or sophisticated ones. Here are broadly classified into two: monoprogramming and multiprogramming. Monoprogramming means in memory manager, monoprogramming means only one process will be run in the memory in addition to the operating system. Only one memory is run in the operating system. This is referred to as monoprogramming, whereas multiprogramming means it allows multiple programs to run in parallel or concurrently. That means it divides the memory among concurrently running process and the operating system. That means a given memory is divided into sub-memories in order to run these multiple programs. This is said to be multiple programming, whereas monoprogramming means only one process will be in memory. So the memory is not divided. So Partitioning of a memory is one of the techniques applied in operating system. In order to run multiple programs in parallel or simultaneously, a memory should be partitioned. There are two partitioning options here, that is fixed partitioning and dynamic partitioning. Fixed partitioning means partitioning is done before the process comes to memory. This technique is called partitioning, fixed partitioning, or partitioning fixedly. Whereas dynamic partitioning means dynamic partitioning means partitioning is done when process requests memory space. That means during the execution of the process, the memory can be partitioned. Whereas fixed partitioning means it is already a pre-configured partitioning one. Next, fixed partitioning. It is the simplest and the older partitioning techniques that commonly used. It divides the memory into fixed number of equal or unequal sized partitions. It divides, again, memory is divided into equal sized or unequal sized. The partition can be done by the operating system or the operator when the system is started. The partitioning can be done by the operating system. That means the partition technique should be implemented by the operating system or the operator when the system is started. Various fixed partitioning techniques are there: equal sized fixed partitioning and unequal sized fixed partitioning. Equal sized fixed partitioning means the memory is partitioned into equal sized partitions. That means a given memory is divided into equal sized. For example, if the memory size is 500 GB, this 500 GB is divided into equal sized partitions. For example, in order to divide this memory into two equal size, so 500 GB divided by 2, that is 500, 200, 250, 250 is partitioned. So this techniques of partitioning is said to be equal sized fixed partitions. Whereas any process whose size is less than or is equal to the partition size can be loaded into any available partition. That means the size of the process must be less than or is equal to the size of the memory. That means the memory, the partitioning memory, unless process may run out of memory. That means this process may not run in a computer system. If all partitions are occupied when the processes that are not ready to run, one of these processes is swapped out. Look, if all partitions are occupied with the process that are not ready to run, one of the processes swapped out and the new process loaded, or suspended process is swapped in and loaded. That means if there is no space, then some of the processes are stored or in waiting list, whereas others is under execution. Then if a given process wants to enter into execution, it needs a memory so that one process is released from memory and the new process enters into a memory. What are the problems of equal sized fixed partitioning? One is the program may be too big to fit into the partition. This is the first problem. The second one is insufficient use of memory due to internal fragmentation. Because internal fragmentation is the technique in which there is a wasted space internal to the partition due to the fact that the process loaded is smaller than the partition. That means the size of the process is greater than the partition size or the memory. This problem is said to be internal fragmentation. The second techniques of fixed partitioning is said to be unequal sized fixed partitioning. Unequal sized fixed partitioning. Okay. Unequal sized fixed partitioning, memory is partitioned into unequal sized, or this partitioning size is not equal. In this case, there are two memory allocations, that is multiple queue and single queue. Using multiple queue, each partition has its own queue. A process is assigned to the smallest partition in which it will fit and it can only be loaded into the partition it belongs. That means if a game process requires 2 megabytes of memory, so the 2 megabytes of memory is assigned to this process. If there is 5 megabytes of memory, 7 for example, 10 megabytes of memory, this process only requires 2 megabytes of memory, so that the memory space 2 megabytes is assigned for this process. This is an equal sized fixed partitioning. This is more flexible one as compared to equal sized fixed partitioning. What is the advantage? Minimal internal fragmentation as compared to an equal sized fixed partitioning. Disadvantages: some partitions may remain unused even though processes are waiting in some other queue. This is the disadvantage of an equal sized fixed partitioning. When this using single queue, the smallest available partition that can hold the process is selected. The smallest available partition first selected. Whenever the partition becomes free, the process closest to the front of the queue that fits in it could be loaded into the empty partition, since it can use internal fragmentation. Another technique suggests to search from the queue the one that best fits to the now empty space. The advantage of single queue is partitions are used all the time, and the disadvantage is when best fit is searched, it will not give a small job based service. They are interactive. This one. So memory must be managed properly and effectively. Memory usage management. To keep free and allocated areas, it is possible to use an array of data structure. So the advantage of fixed partitioning is simple to implement and requires minimal management overhead. The disadvantage is inefficient, limited number of active processes. A program may be too long to fit in any of these partitions. This is a disadvantage of fixed partitioning. The second type of partition technique is dynamic partitioning. Dynamic, as the name implies, the partition is dynamically, or the memory is dynamically partitioned. Partitions are created dynamically during execution. If a game process requires 2 megabytes, it's automatically created during execution. The size and number of the partitions vary throughout the operation of the system, unlike that of fixed partitioning. So the process will be allocated exactly as much memory they require. If a game process 1 requires 5 megabytes, 5 megabytes of memory is partitioned and assigned to this process. Dynamic partitioning leads to a situation where there are a lot of small useless holes in a memory. This phenomena is called external fragmentation. So what's compaction? Compaction means combining multiple useless holes into one big hole. That means if there is small useless holes in a memory, these useless holes are merged into one. This technique is compaction. The problem of memory compaction is that it requires a lot of CPU time for compaction. For instance, a 32 megabyte memory machine can only copy 16 bytes per microsecond. It takes 2 seconds to compact all of this memory. That means it takes time for compaction. A process has 3 major sections: stack, data, and code. Within a fixed partition, the space given to the process is usually larger than it's asked for, and hence the process can expand it. With dynamic partitioning, since the process is allocated exactly as the process requires, or the process requires a memory, it creates an overhead of moving and swapping a process whenever the process is growing rapidly. That is the disadvantage one actually. It expected that most processes will grow as they run, so it's a good idea that to allocate a little external memory whenever a process loads into the memory. As shown in the following diagram, that extra space is located. Yes, there is stack, there is data, and there is a code here. If a process runs out of extra space allocated to it, either it will have to become it will have to move to able to hold with enough space or swap it out of memory until largest enough hole can be created, or it may kill the process. Killing the process means just stopping that process in execution. So this is some of the types of memory partitioning, that is the fixed one and the dynamic memory partitioning. In the next video we will see the memory management scheme. Thank you for watching. Don't forget to like, share and subscribe this channel. Thank you.